So we have the hydrogen bonding, we have water as a universal solvent, and we looked at how we can create solid, liquid, and vapor forms. There is additional details here that we will come back to when we look at the heat budget of the ocean, for example, because you have the vaporization where you add energy to liquid water, make it boil and create steam, gaseous form of water. But there is another way to produce vapor form, and that's called evaporation. Obviously, evaporation doesn't happen at boiling temperature. It is happening at much lower temperatures, even at room temperature. For example, when you sweat, your body is evaporating water from the skin, and it's cooling down the skin. So why does evaporation cool the body from which the water is evaporating? So if ocean is evaporating water, ocean cools down. Why does that happen? You have also sublimation, where you can go directly from solid form like ice into water vapor. This is very rare, but this is a sublimation which can happen depending on the difference in the vapor pressure, and there are lots of other details that we won't go into, but that also requires energy. So the other side of sublimation is deposition, where water vapor can directly get deposited as solid. So we won't talk much about sublimation and deposition. They're not very important in the Earth system. But it is these properties, these unique thermal properties of heat and temperature and the change of state, that give us, in fact, weather and climate. There is another force involved here called the van der Waals forces, which are weak interactions between molecules, which are very weak when the molecules are apart, like in a water vapor form, but they become stronger as the molecules come close to each other. They are in addition to the hydrogen bonds that we talked about. So energy has to be added for molecules to overcome these van der Waals forces. So it is these different kinds of forces involved in the structure of the water molecule that give us the unique properties. So where does the energy come from for evaporating water in the human body? Obviously, when we are feeling very hot, the body's thermometer, the thermostat, wants to cool the body, so it sweats, and the sweat is evaporated by either the air conditioning you have on, or the fan you have on, or you are outside and the wind that is picking up the water molecules from your skin and pulling it away. So essentially the hydrogen bonds are broken, and that escape from of the water molecule from the other molecules is accomplished by taking the energy of the hydrogen bonds. Hence water loses the energy, hence the water cools down. This is why your skin feels cooler when the sweat evaporates from your body, and this is the same process which cools the surface of the ocean or the soil or the lake or the leaf or whatever when water molecules escape through evaporation.